Hi students, let us see how to prove that the null matrix is both symmetric and skew-symmetric. So here they have given that a null matrix. We have to prove that it is both symmetric and skew-symmetric, right? So let us assume, let us take as let A be symmetric and skew-symmetric. Let A be symmetric and skew-symmetric. And since A is symmetric, we know that A here it is symmetric. And if A is symmetric, what can we conclude? We can conclude that A transpose will be A. The reason is since A is symmetric. Since A is symmetric, we can tell A transpose will be equal to A. AT, or this is both stands for A transpose, and A transpose means we can write it as A J I equals A will be A I J for all I and J. This symbol stands for all. This is how you read the symbol, for all. So A transpose will be equal to A, that is A transpose can be written as AJI, and that would be equal to A, which can be written as AIJ for all I and J. And now, so this was the case for symmetric. Now, if A is skew-symmetric, if A is skew-symmetric, what can we conclude? We can tell that A transpose will be minus A. A transpose will be minus A. And now this, I'm giving it as equation 1. This is my equation 1. And A transpose is what? A transpose is A J I. That would be equal to minus A is AIJ, minus AIJ. Now this I'm giving it as equation 2. And now, I made a mistake here. This is, just a minute, let me just erase it off. Yeah, now here this equation is equation 1. This is first equation. This is equation 1, this is equation 2, and what I'm going to do is I'm going to add equation 1 and 2. Adding equation 1 and 2, what would I get? AJI plus AJI is equal to AIJ minus AIJ. AIJ minus AIJ would become 0. So here this would become 2AJI is equal to 0. AJI equal to 0 for all I comma j, for all I and j. Therefore, what can we infer from here? We can say that therefore A is a null matrix. Hence proved. You should also write hence proved. So to prove that a null matrix is both symmetric and skew-symmetric, first we take A to be both symmetric and skew-symmetric, and if A is symmetric, then we know that A transpose will be equal to A. A transpose will be AJI, and that would be equal to A, which is AIJ for all I and J, and that we give as equation 1. Now second case, A is skew-symmetric. If A is skew-symmetric, what? A transpose will be the negative of A. That is AJI would be equal to minus AIJ, and that I give as equation 2. Now I'm going to add equation 1 and 2, and on adding equation 1 and 2, we get AJI plus AJI equals AIJ minus AIJ, and this whole term will get cancelled. It'll become 0. AJI plus AJI to AJI. AJI is equal to 0 for all I and J. And if AGI is 0, then we can conclude that A is a null matrix, hence proved. So hope you understood this, and if you have any doubt, please put on your question in the comment section. Till then, stay tuned. Bye bye.